Increasingly, artificial intelligence systems known as deep learning neural networks are used to inform decisions vital to human health and safety, such as in autonomous driving or medical diagnosis. These networks are good at recognizing patterns in large, complex datasets to aid in decision-making. But how do we know they're correct? Alexander Amini and his colleagues at MIT and Harvard University wanted to find out. They've developed a quick way for a neural network to crunch data, and output not just a prediction but also the model's confidence level based on the quality of the available data. The advance might save lives, as deep learning is already being deployed in the real world today. A network's level of certainty can be the difference between an autonomous vehicle determining that it's all clear to proceed through the intersection, and it's probably clear, so stop just in case. Current methods of uncertainty estimation for neural networks tend to be computationally expensive. But Amini's approach, dubbed deep evidential regression, accelerates the process and could lead to safer outcomes. We need the ability to not only have high-performance models, but also to understand when we cannot trust those models, says Amini, a PhD student in Professor Daniela Roos' group at the MIT Computer Science and Artificial Intelligence Laboratory, CSAIL. This idea is important and applicable broadly. It can be used to assess products that rely on learned models. By estimating the uncertainty of a learned model, we also learn how much error to expect from the model, and what missing data could improve the model, says Roos. Amini will present the research at next month's NER-IPS conference, along with Roos, who is the Andrew and Erna Viterbi Professor of Electrical Engineering and Computer Science, Director of CSAIL, and Deputy Dean of Research for the MIT Stephen A. Schwarzman College of Computing, and graduate student. Efficient uncertainty after an up and down history, deep learning has demonstrated remarkable performance on a variety of tasks, in some cases even surpassing human accuracy. And nowadays, deep learning seems to go wherever computers go. It fuels search engine results, social media feeds, and facial recognition. We've had huge successes using deep learning, says Amini. Neural networks are really good at knowing the right answer 99% of the time, but 99% won't cut it when lives are on the line. One thing that has eluded researchers is the ability of these models to know and tell us when they might be wrong, says Amini. We really care about that 1% of the time, and how we can detect those situations reliably and efficiently. Neural networks can be massive, sometimes brimming with billions of parameters. So it can be a heavy computational lift just to get an answer, let alone a confidence level. Uncertainty analysis in neural networks isn't new. But previous approaches, stemming from Bayesian deep learning, have relied on running, or sampling, a neural network many times over to understand its confidence. That process takes time and memory, a luxury that might not exist in high-speed traffic. The researchers devised a way to estimate uncertainty from only a single run of the neural network. They designed the network with bulked-up output, producing not only a decision but also a new probabilistic distribution capturing the evidence in support of that decision. These distributions, termed evidential distributions, directly capture the model's confidence in its prediction. This includes any uncertainty present in the underlying input data, as well as in the model's final decision. This distinction can signal whether uncertainty can be reduced by tweaking the neural network itself, or whether the input data are just noisy. confidence check. To put their approach to the test, the researchers started with a challenging computer vision task. They trained their neural network to analyze a monocular color image and estimate a depth value, i.e., distance from the camera lens, for each pixel. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.